Is AI about to break the power grid? The future everyone's chasing, automated everything, generative intelligence, models that think better than you, has a physical price. It's measured in megawatts, and it's coming due. See, AI doesn't run on dreams, it runs on data centers, and data centers run on electricity. More of it than our current infrastructure knows how to deliver. In Europe alone, power demand from data centers is expected to more than double by 2030, from about 62 terawatt hours now to 150 plus. That's not a blip. It's one of the biggest new forces hitting the grid. By the end of the decade, AI-powered data centers could soak up 5% of Europe's total electricity. That's more than most countries' entire industrial sectors. But this isn't just about volume, it's about timing. AI data centers don't gently sip power. They slam the grid with high density demand spikes, especially during training runs on clusters of GPUs burning up to 120 kilowatts per rack. That's a rack, not a building. Let me break this down. One AI training run has the equivalent energy demand of an entire small city. Now multiply that by every hyperscaler in the game. Google, Amazon, Microsoft, each racing to scale AI infrastructure 10 times by 2030. That's where the crisis comes in. The grid wasn't built for this, especially not in Europe, where power demand's been flat for decades and transmission expansion moves at a glacier's pace. Some cities, like Dublin and Amsterdam, have literally paused new data center builds, not for lack of real estate, but because the wires can't handle it. And it gets worse. Lead times to get power to a new data center site, 3 to 5 years. Transformers, switchgear, UPS systems, up to 2 years backlogged. The result, AI capacity is growing, but electricity access isn't. This isn't just a delay, it's a structural mismatch. So what happens when we try to push AI through an underpowered pipe? We decentralize. Some hyperscalers are moving training workloads to cold climate outposts in Finland or Wyoming, anywhere the grid still has slack. Others are co-locating next to power plants or building their own backup fleets of gas turbines and hydrogen fuel cells. It's the modern version of digging your own well. Ironically, AI's demand is forcing a broader rethink of how energy is produced and used. Hyperscalers are now among the biggest buyers of green power globally. But even those flashy power purchase agreements, PPAs, can't guarantee supply exactly when AI needs it. That means we're headed toward a model where some data centers effectively become mini power plants just to keep uptime intact. And if you think better chips will solve this, not so fast. More efficient chips don't shrink energy needs. They just enable bigger models. It's the treadmill effect. The more efficient we get, the more we try to do. A smarter AI doesn't use less power. It just solves harder problems while pulling even more juice. So let's ask the question everyone's avoiding. Is the AI revolution bottlenecked by electrons? The answer is yes. Power is now the gating factor for AI growth, not talent, not capital, not even compute hardware. Electricity access, period. Some analysts estimate we'll need to build 2x the global data center capacity of the past 20 years, again, by 2030. But without a massive acceleration in transmission and clean generation, AI's ambitions will hit the wall. Here's where it gets even more interesting. Data centers are now competing with EVs, heat pumps, and reindustrialization for green electrons. And while data centers can pay top dollar, that creates a dangerous imbalance. If critical public infrastructure gets outbid by GPT-6, we'll have made a Faustian bargain. So where does this go? If we don't solve for high-density, always-on dispatchable clean power, then AI will be forced to slow down. Or worse, relocate to wherever the grid still works. That's already happening. Europe's lag is America's gain. For now, here's your call out. If your business or country is betting big on AI, ask one question: what's your energy plan? Because if we don't build smarter, faster, greener power systems, the next AI breakthrough might just be a blackout. If you found this breakdown useful or worrying, drop a comment. Where do you think the AI build-out hits the next wall? And as always, don't forget to like, subscribe, and share this with someone who still thinks ChatGPT runs on cloud magic. This is your fake CTO signing off.